Hi students, welcome to ACE online platform. Now in this session, we will be focusing on SSC JE, exam preparation strategy, and we will be targeting for the subject electromagnetic theory or electromagnetic fields. It's a very short subject, but a very sizable number of questions was asked from this topic. Fine. So now we'll look at the first, we'll be dealing with some important topics which was noticed in the previous papers. Fine. Okay. Now it's a very fundamental questions were asked. You can take them as a part of your physics also. Fine. So let me turn the page here. So this is syllabus. Fine. So electrostatics, magnetostatics, and then time varying fields. Electrostatics, magnetostatics, and time varying fields. Fine. So from the electrostatics, what questions can be expected? The questions which are related to the Coulombs Law, electric field definition, different types of charges like a point charge, line charge, surface charge, volume charge, Gauss Law, potential concept, and capacitors. And in the magnetostatics, Biot-Savart's law, okay, and different types of currents like a line current, sheet current, volume current, okay, Gauss Law for magnetic field, and inductor, and so on. In the time varying field, especially will be focusing on what is called a Faraday's law. Fine. Especially these are the two major topics. Faraday's, this time varying fields. From the time varying fields, we are having only one topic, what is called a Faraday's law. Anyhow, that Faraday's law will be covered in your machines. Fine. Okay. Now, so what is the weightage given for this subject for SSC JE is minimum 6 to maximum, minimum 4 to maximum 6 questions were noticed in your previous papers. Okay, fine. So now let us take some topics here, and let us try to see how to, let us try to understand the concept and how confidently you can answer the questions. Fine. Okay. So now let us start with some topics here. And before going into that, what you must focus here is the concepts are very simple. The only thing is you should remember the varieties of formulas. Okay. Questions are formula based and simple concept based questions. Theoretical as well as the numerical questions were noticed in your previous papers as far as this subject is concerned. Fine. So now observe here. Let us start with the Coulombs law. Yes, you have been learning this Coulombs law right from your high school physics. Fine. What is the Coulombs law? If there are two charges are there, this Coulombs law comes under the electrostatics. Now let me check out how many of you have joined. Okay, fine. Let us start with the Coulombs law. It is a very fundamental law. You would have learned this one in your physics also, but this is a part of anyhow electrostatics. Fine. See here, what is this Coulombs law? If there are like charges are there, like a positive, positive, negative, negative. So like charges will repel each other and unlike charges will attract each other. Fine. So what is the first statement you can check out here? Like charges repel each other and unlike charges attract each other. What are the like charges? Positive, positive. Like charges are positive, positive. Negative, negative are the like charges. What are the unlike charges? So this one there will be a repulsion force between these two things. And what is the unlike charges? Positive, negative, negative, positive. Fine. So there will be a force of attraction between them. That is the first statement. And what is the second one? There is an experimental result was conducted. Experimentation was done by the Coulomb himself, and he has given some experimental results. The Coulombs law talks about what is the nature of the force between the two charges. Fine. Okay. So what is the nature of the force between the two charges? The force between two charges is proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay. Let us try to understand this law with the help of some diagram. Let me turn the page here. Yes, good evening, hi. So let us consider the two charges here. It is a Q1, it is a Q2. Okay, fine. So force is anyhow vector. What is a vector? It has got a force as a direction, isn't it? Force will be acting in certain direction with certain magnitude. Here, the force between two charges is also a vector, obviously. It is the electric force. Fine. But in the most of the in your previous papers, the questions was related on the only the scalar value. I'll write the vector scale only on the scalar value. I'll write the vector form, but I'll ask you to remember only the scalar form. Fine. So let us take distance between. If I assume these two charges to be a positive charges, this Q1 and Q2 are the positive charges. If they are positive charges, what happens? They'll repel each other. Fine. So this will exert force on this one in this direction. This will exert force on this one in this direction. Isn't it? Okay. So they'll repel each other. Fine. So I want to find out the force on this due to this. Fine. So I'll frame a vector. I'll frame a distance from here to here. The distance is, let us say, r vector, and there is a unit vector here. What is the unit vector? It talks about the direction. So the direction is like this. So here is a force beta. Here it is a force. Force between two charges, Q1 and Q2. And what is the force on this due to that one? In this direction. Fine, I am not considering that. So it is a unit vector. What is a unit vector? Vector by its magnitude. How unit vector can be written? Vector by its magnitude. This is a unit vector. Let me go back here. So what is this law is talking about? The law is talking about what is called the force between two charges is proportional to product of the charges, isn't it? Suppose, what is the force between these two charges Q1 and Q2? If I put here bar, what does that indicate? It indicates the vector. If I remove that bar, it just indicates the magnitude. Fine. So what is the force between the two charges? The force between the two charges is proportional to the product of the charges, Q1 into Q2. Yes, that means if there is a very high charge is there, what happens? There will be a high force of attraction or repulsion between them. And what is the other statement? The force between two charges is proportional to the product of the charges and is inversely proportional to the square of the distance between them. Okay. So if I increase the distance between these two charges, what happens? The force between these two things decreases. So force is proportional to 1 by r square. It is experimental result. Okay. Suppose if I increase the distance, what happens? Force between the two charges decreases. Clear? Is that clear? Fine. So just combine these two things. If you combine these two things, so the force is proportional to Q1 into Q2 divided by r square. Clear? Okay. And there is a proportionality constant here. What is the proportionality constant? F is equal to 1 divided by 4 pi epsilon into Q1 Q2 divided by r square. Fine. So this is a scalar form. Most of the questions will be from this scalar form only. This is a scalar form. Just it is talking only about the magnitude. Fine. What is this epsilon? I will talk about that. What are the units for the force? Units also important for our exam, newtons. Fine. I want to write this one in the vector form. Mostly questions cannot be expected on that, but I will write here. So what is the force direction? The force direction is line. I want to find out, if I want to find out the force here, direction, what is the force? Is it like this or like this or like this? It would be like this. Line joining 2 points. Okay. So line joining 2 points. This is the force direction. Suppose, for example, if the charge is somewhere here, it is Q3. Then what is the force direction on this one? Line joining 2 points. This is a force direction. Okay, then the unit vector will be like this. Okay, so the unit vector talks about what is called a direction with the magnitude 1. So if I want to write this one in the unit in the vector form, what happens? F vector, I am writing the bar. What does the bar indicates? It is a vector. It has got a direction as well. Fine. So which is equal to Q1 Q2 divided by 4 pi epsilon r square into r cap. Clear? Yes. So that is a vector form. Clear? Okay, fine. Now let me talk about this epsilon. What is this epsilon? That is called permittivity. Okay, it is a medium parameter. Epsilon is equal to epsilon naught epsilon r. See here, the force between the two charges, it depends on the magnitude of the charges. Okay, yes, if you consider the very high charge, the force of attraction or repulsion between these two charges will be high. Point number 1. Point number 2, if I increase the distance between these two charges, what happens? The force between these two charges will going to decrease. If I decrease the distance, force increases. Not only these 2 points, there is a one more point, what is called a medium. Okay, in which medium you are placing these charges? Yes. So in this is what is this epsilon? It is a medium parameter. What it is? It is a medium parameter. Fine. So this epsilon is a medium parameter. What is this epsilon naught? It is called absolute permittivity, whose value is, you have to remember this one. Let me turn the page here. I'll go to turn the page. So what is this epsilon? It is a medium parameter. Epsilon is equal to epsilon naught epsilon r. This is called permittivity. What is this epsilon naught? Is equal to 1 by 36 pi into 10 to the power of 9, 8.854 into 10 to the power of minus 12 farad per meter. So you must remember this value. Okay. So 1 by 36 pi into 10 to the power of 9, 8.854 into 10 to the power of minus 12 farad per meter. You must remember this one. And what is this epsilon r? Is equal to 1 for the air. And this value is greater than for other than air. It is for other than air. Okay. So what this is called? This is permittivity. This is absolute permittivity. This is called relative permittivity. Okay, you have to remember there is no units for this relative permittivity. Okay, you must remember along with the units. Units also important for our exam. Okay, friends, fine. So this is a thing you have to remember from this Coulombs law, this expression. Okay, if nothing is mentioned in your question regarding this epsilon r, you have to consider for the air. Fine. So that is the assumption you have to do. Now let us take some question here and confidently we can answer those things. See, this is one of your previous question. Any answers from your side? Speak out. Yes, come on, speak out. Try to answer this one. Coulombs law for the force between the electric charges closely resembles or something similar to. So the Coulombs law is something similar to what? He has given in the option Newton's law of motion, law of conservation of energy, Gauss theory, Newton's laws of gravitation. Anita, Newton's law of motion. Yes? Any other answers? Speak out. Option D, isn't it? See, in your physics, you would have learnt. Suppose if there are two bodies are there with some mass m1 and m2. There is a body here m1. There is a body here m2. And the distance between these two things, let us say r. Yes. What is the gravitational force between these two things? This is gravitational force is a proportionality constant into m1 into m2 divided by r square. This is a gravitational force between two charges. So just now I have shown you, if there are two charges are there, q1, q2. What is the force between these two things? Let us say it is electric force, which is some proportionality constant 1 by 4 pi epsilon into q1 into q2 into r square divided by r square. So you can compare this one. It is a Newton's law of gravitation. So this is a proportionality constant. Yes, here this is a proportionality constant. So it is a product of two masses, here product of two charges, divided by r square, divided by r square. Yes. So this Coulombs law resembles, Coulombs law is similar to what you have learnt in your physics as a Newton's law of gravitation. That is the thing. Clear? Okay. Let us have one more question. It is a numerical. Try to solve this one. Come on, speak out. A charge 8.85 into 10 to the power of minus 9 coulombs is located in the vacuum at 2, 3, 1 and another charge of 4 pi into 10 to the power of minus 3 coulombs is located at 2, 2, 1. The magnitude of the force between the charges is. Okay, is asking what is the magnitude of the force between these two charges. Any answers? What is the formula need to, is asking only for the magnitude. What is the force between two charges? It is this one. He said vacuum. Okay, epsilon will be equal to epsilon naught. So can you try this one? Now come on, speak out. Please do the calculation. Yes, any answers from your side? Come on, speak out. So there are two charges here, 8.85 into 10 to the power of minus 9. Where this is located? 2, 3, 1. What is another charge? It is 4 pi into 10 to the power of minus 3 coulombs. Where this is located? 2, 1. What is the distance between these two things? You need to find out distance between these two things. Clear? So what is the force expression I have given from the Coulombs law? And he said vacuum. Yes. So for the vacuum you have to consider epsilon is equal to epsilon naught, whose value is 8.854 into 10 to the power of minus 12. Fine. So what is the force between the two charges? It is equal to Q1 into Q2 divided by 4 pi epsilon naught into r square. Correct? Someone answered. Very good, gate. Rajakumara Swami, very good. So it is the product of the two charges. And one more thing, what is the distance between these two charges? How do you find out the distance here? What is the distance between 2 points? Which is 2 minus 2 whole square. 2 minus 2 is 0 square. Plus 2 minus 3, it is minus 1 or 3 minus 1. Anyhow, you are finding the magnitude here. So it is 1 square or minus 1 square, doesn't matter. 1 minus 1, it is 0 square. So square root of 1 square, minus 1 square is 1, square root of that one is 1. Clear? Okay, substitute all the values. Here it is 8.85 into 10 to the power of minus 9 into another charge is 4 pi into 10 to the power of minus 3 divided by 4 pi into epsilon naught is 8.854 into 10 to the power of minus 12 into 1. Okay. So anyhow, you can take it as you can just discard that 4 here. So these two cancel, these two will cancel. Here 10 to the power of minus 12, here also 10 to the power of minus 12. So the numerator is same as denominator, it is 1 Newton is the answer. Clear? Okay. Let us have one more question. Read out the question here. Two charges are placed at the same distance apart, some distance apart, not same. If the glass slab is placed between them, the force between the charges will, what happens? There are two charges are there. So you have to assume those two charges to be in the air. Now between those charges, we are introducing the glass. What happens? Any answers? Yes, what is the answer for this? Theory question, number of times this kind of models was noticed. Suppose initially, let us say there is a air, nothing is mentioned, so I have to consider it as a air. So I will call it as a FA. FA is equal to Q1 into Q2 divided by 4 pi epsilon naught into R square. Yes, if there is a air between the two charges. Now you are introducing what is called a glass between the two charges. I will call this as a FG. FG is equal to Q1 into Q2 divided by 4 pi epsilon naught epsilon R into R square. Clear? So here there is some extra term here, epsilon R for the glass. Okay. One thing is very clear, how much that epsilon R we do not know, but epsilon R will be greater than 1. Yes. So there is no factor here. Here epsilon R will be, you can say epsilon R value is 1. Here epsilon R, where epsilon R is greater than 1. So in the denominator, if it is a greater than 1, so this will be less compared to this one. There is nothing like an extra term here. So in the denominator, you are getting some value. So that will going to reduce. So what happens here? Fg will be less than Fa. Clear? So decreases. Decrease. Option C. Clear? So scalar form is enough for us. Scalar form is enough for us. Let us take one more question. Directly, this was SSC JE question. Directly theory question, you can answer that. Directly from the definition of the Coulombs law. Which of the following statements about the force between the two charges is true? Unlike charges repel each other. No. Unlike charges means positive, negative. They will attract. So this statement is wrong. Second one, like charges attract each other. No, positive, positive will not attract. This is a statement wrong. No force exists between. A force of repulsion exists between two like charges. Yes. So this is a correct statement. No force exists between two unlike charges. No. So option D is the answer. Fine. Next question. See. You need to think a little bit about this one. Yes, what is the answer for this question? A charge Q is divided between 2 point charges. What should be the value of this charge on the objects so that the force between them is maximum? Okay. See here, there is a charge Q. There is a charge Q. It's being divided into 2 point charges. Here it is Q1, here it is Q2. What is this Q1 plus Q2? Is equal to Q. Yes. So he is asking in what proportion I have to divide so that the force between those two things will be maximum. Fine. So first charge it is Q by 3. Next charge will be 2Q by 3. Here first charge is Q by 2. Next charge will be Q by 2. Isn't it? If it is a Q by 2, then this will be a Q by 2. Why? Because addition of these two must be Q. This is Q by 4. If this is Q by 4, this must be 3Q by 4. This is Q by 10. This must be 9Q by 10. Because addition of two charges must be equal to total charge Q. Fine. You can answer the question from the options here. And we know that how the force between the two charges is dependent on the force between the two charges is equal to Q1 into Q2 divided by 4 pi epsilon r square. So the force is proportional to product of two charges Q1 and Q2. Okay. So now let us take the first option here. So whichever is having the highest product of charges, that will be the answer. Fine. Any answers from your side? Let us take the first option. What is the first option? Q by 3. One of the charge is Q by 3. The other charge will be 2Q by 3. Now let us take the product of these two charges. How much is the product? It is 2Q square by 9. Now let us take the second option. It is Q by 2. Another charge will be Q by 2. What is the product of the charges? It is Q square by 4. Option C, Q by 4. What is another charge? 3Q by 4. What is the product of the charges? It is 3Q square by 16. Option D, here it is Q by 10. The another charge is 9Q by 10. What is the product of the charges? 9Q square by 100. So which is the maximum among them? That will be the answer. That is what he is asking. Okay. What should be the values of this charge on the objects so that the force between them is maximum? So what is the maximum among them? Here it is 2 by 9. Here it is 1 by 4, 3 by 16. It is 9 by 10. So among all these things, this 1 by 4 is the maximum. So what is the answer? Option B. So you need to equally divide the charges between the two bodies so that the force between those two charges will be maximum. Clear, friends? So this is all about, see, this is how you can expect the questions. I have touched the varieties of questions on this Coulombs law. Okay, let us take one more topic here. Gauss law. There is one more thing I have considered here before going into the Gauss law. There is one more charge. One more question. A solid non-conducting sphere of radius 1 meter carries a total charge of how much? 10 coulombs, which is uniformly distributed throughout the sphere. Determine the charge density of the sphere. Is asking charge density. You can look at the options here. Options are having coulomb per meter cube. Is asking charge per meter cube. So the charge is distributed inside the sphere. Is asking charge per meter cube. You can check out the options. Fine. So charge per meter cube, it is called volume charge density, or simply it is called volume charge. So volume charge is equal to Q by volume. What is the total charge here? It is 10 divided by what is the volume of the cube? It is 4 by 3 pi r cube. So here it is 2.5 into 3 divided by 5 pi, 7.5 divided by pi. So pi is approximately 3.14. So anyhow, without any calculator you can answer the question. So it is something 3, 7.5 divided by 3. How much is this? 2.5. So the answer must be, and this pi is not exactly 3, it is greater than 3, 3.14. So answer should not be 2.5, less than 2.5. Yes? So less than 2.5, in and around the 2.5. So option D is the answer. Option D is the answer. Yes? That is how you can answer the things. Good, very good. Okay, now let us have one more concept here. Gauss law. What is the Gauss law? There are only two lines need to be remembered from the Gauss law. This is also important. What is the Gauss law? How can you remember this Gauss law in short? Read out the statement what I have given for the Gauss law. Gauss law talks about net electric flux. Read out the statement. The net electric flux. The net electric flux coming out of any closed surface is equal to total charge enclosed by that surface. Net electric flux coming out of any closed surface is equal to total charge enclosed by that surface. Okay. So net flux, how can you interpret the flux? Number of lines crossing the given surface is called flux. So there are only 2 points need to be remembered from this Gauss law. There are so many applications for the Gauss law. Okay. Just we'll take one definition and we'll take some expected questions here. Expected or model of questions, I would say. But there are a lot to be discussed regarding this Gauss law. Okay, fine. So you should understand the importance of this. So there are only 2 points here. Net electric flux is equal to charge enclosed. I will give the intuition and logic here. How can you understand this one physically? So how you can write electric flux is represented with the psi e. Units, it is a net electric flux is equal to charge enclosed. ENC means what? Charge enclosed. That means you need to consider only the charge which is inside the closed surface. Okay, let me show you with some example here. Let us consider the closed surface. Something like a mango, something like a balloon, isn't it? It is a closed surface. Inside this one, let me put some dots here. Why I am putting these dots? To create the feel that it is a three-dimensional one. Fine. Inside this one there are charges here. Q1, Q2, Q3, Q4, so on up to Qn. And outside this one there are charges. What are they? Q1 dash, Q2 dash, Q3 dash, Q4 dash, so on up to Qn. Clear? Let us take this the S0 surface. Now, what is the net electric flux coming from the S0 surface according to the Gauss law? What is the flux? To put it in a simple words, number of lines crossing the surface. Number of electric field lines crossing the surface, that is how you can interpret the flux. Fine. According to the Gauss law, so what is the net electric flux coming out of from the S0 surface? I can write it like this. So according to the Gauss law, net electric flux which is coming from the S0 surface is equal to charge enclosed ENC. What is the charge enclosed by the S0 surface? Charge enclosed means what? Charge which is inside. So here it is Q1 plus Q2 plus Q3, so on up to Qn. Only you should consider the charges which are inside and you should discard the charges which are outside. Okay, fine. Then one can ask, why like that? How can you interpret this one? To put it in a simple words, let us say if the charge is outside, you are not consider the charges which are outside. Are they not giving for any flux? No doubt, undoubtedly, each and every charge will be associated with some flux lines. But the Gauss law talks about net flux. Okay, so if the charge is outside, let us say how many charge, for example, 3 lines are entering, 3 lines are leaving. These lines are puncturing that one and coming outside from other side. 3 lines are entering, 3 lines are leaving. So what is the net here? 3 minus 3, net. 3 entering, 3 leaving, net is 0. So net flux contributed by the charge which is outside the closed surface is 0. But if the charge is inside, let us say this is giving some 3 lines. How many lines are leaving? 3 lines. How many lines are entering? No lines. So 3 minus 0. So there is a 3. So the net electric flux will be contributed only by the charge which is inside. Clear? Okay. Now let us take net electric flux of S1 is equal to charge enclosed. What is the charge enclosed by? I will consider one more surface here. Let me use some other color. I have considered one more surface. Let us say this is a S1 surface. So how much is the flux coming from the S1 surface? It is Q charges and Q dash charges. It is Q1 plus, you have to consider only the enclosed charges. Okay. So what is the enclosed charges means? What are the charges inside the S1 surface is Q1 plus, Q2 plus, Q3, so on up to Qn plus Q1 dash plus Q2 dash, Q3 dash, so on up to Qn dash. That is the story. Clear? Simple thing. What is the Gauss law? I will reiterate again. Just only one point need to be remembered. What it is? Net electric flux. I have underlined that point there. Net electric flux is equal to charge enclosed. Thus, clear? Let us take some questions here to appreciate this concept. Here is a question. Now look at this one and try to answer this. Yes? A charge Q is enclosed by a Gaussian, a charge Q is enclosed by a Gaussian spherical surface of radius r. If r is doubled, then the outward flux is. Yes, in the first case, there is a charge. Now this is enclosed with the sphere of radius r. So what is the net electric flux here? Net electric flux is equal to charge enclosed. What is the charge enclosed by this one? Q charge. Now what you are doing in the second case, you are enclosing this one with the bigger sphere whose radius is 2r. There is a charge here. So the flux coming out of from this one do not depend on the Gaussian surface. It depends only on the charge enclosed. Yes, you have to consider only the charge which is inside. So you are not changing the charge here. In this case and in this case the charge is same. So what happens to the net electric flux? Is equal to charge enclosed Q, same. Yes, remains unaltered. Option D is the correct. Let us take one more question. Yes, read out this one. The electric flux from a cube of side A is phi. What will be its value if the side of the cube is made 2A and the charge enclosed is made half? This is important. So if the charge enclosed is made half, flux also will be, net flux will also become half. Okay. So here simple, the side of the cube has got no meaning, no effect, isn't it? So for the phi, for the charge enclosed, let us say, for the charge enclosed Q, the flux is phi. If the charge enclosed is halved, what happens? This will become phi by 2. That's how simple it is. Yes. So it is a phi by 2. Option A is the answer. Clear? Okay. Fine. Now let us proceed further. So these are all some concepts which are related to the electrostatics. Now let us take a magnetostatics, very popular formula. Magnetic field due to finite length conductor and infinite length conductor. Fine. Number of times questions were noticed on this one. Suppose, see here, there is a current carrying conductor here. So how the current is flowing? Like this. I want to find out what is the magnetic field at a distance of rho. What is the distance? It is a perpendicular distance. From your fundamentals you know that if the current is flowing like this, magnetic field here is circling around this. On this consider, if you on this plane it is magnetic field is inside. Here magnetic field is inside. So the magnetic field is in the angle direction. I will call it as a B phi. I want to write the expression for this B phi. So the expression for B phi, after some derivation, you will going to get the magnetic field expression something like this, which will be dependent on these angles and this angle. Angle made with respect to the corners. What is this angle? Let us say it is alpha 1. This angle is alpha 2. Okay, there is a current carrying conductor. I want to find out what is the magnetic field at certain distance. So I need to see this angle and this angle. What is this angle? It is alpha 1. This angle is alpha 2. Or remember something like this. This is alpha 1 and this one is alpha 2, or something like this. That is how the angles are defined. So according to this one, what is this B? B vector is equal to mu into I divided by 4 pi into rho sin alpha 1 plus sin alpha 2 into phi cap. If you want to write only the vector, only magnitude, B is equal to mu by 4 pi rho sin alpha 1 plus sin alpha 2. Suppose if you want to write for the H, we know that B is equal to mu into H. You can remove this mu here. This is called magnetic flux density, magnetic field intensity. What are the units for this one? Here it is a Weber per meter square. Now I want to modify this formula to the infinite length current carrying conductor. What happens for the infinite length current carrying conductor? You have to see like this. So this angle will become 90 degrees. You have to see like this. This angle also will become 90 degrees. So for the infinite conductor, what you can do? So it is an infinite length conductor. I want to see the corners of this one. Can I see the corners? No. It is infinite extent. So what happens to the angles here? I want to see the corners. Yes, this will become 90 degrees. So alpha 1 is 90 degrees, alpha 2 is 90 degrees. So current is flowing like this, magnetic field here is inside. Magnitude is enough for our exam. Okay, fine. So alpha 1 is equal to alpha 2 is equal to 90 degrees. So substitute those values here, only magnitude. B is equal to mu by 4 pi rho into sin alpha 1. What is the sin alpha 1? It is 90 degrees plus 90 degrees. So it is 1 plus 1. So B is equal to mu into I divided by 2 pi rho. Units are Weber per meter square. So, and if what is the H? H is equal to I by 2 pi rho. In the previous one, what is the H here? H is equal to, you can just remove this mu, it is I by 4 pi rho into sin alpha 1 plus sin alpha 2. Units are ampere per meter. Here it is ampere per meter. Let us take, based on these formulas, how you confidently we can answer the questions. See here. A square loop of D, side D carries a current of I amperes. The magnitude of magnetic field intensity at its geometric center is, just you can write, at its center is. See here, there is a current carrying conductor like this. I'll take one question and I'll give one shortcut here. That will save our time. There is a current is flowing like this. He is asking what is a magnetic field at the center. Yes, what is the magnetic field at the center? Current is flowing like this. If I put my thumb like this, my fingers, so the magnetic field direction is like this. Here also if I put my thumb like this, magnetic field direction is like this, here like this, here like this. So what is happening here? Magnetic field is getting added up here. So the magnetic field here is due to this section plus this section plus this section plus this section. Instead of that, what you can do, just you can find out the magnetic field due to the only one section and you can multiply with the number 4. Fine. So here I'll rewrite this diagram. So here is the thing. What is this angle? This angle is pi by 4, that is 45 degrees. This also 45 degrees. Clear? What is the overall distance from here to here? The here to here distance is D. And what is the perpendicular distance from here to here? It is D by 2. How much current is flowing? It is I amperes. Let me turn the page here. What is the formula? H, I'll call it as HS, means what? Magnetic field due to each side, which is equal to I by 4 pi rho into sin alpha 1 plus sin alpha 2. Substitute all the values here. So Hs is equal to I by 4 pi into perpendicular distance. What is the perpendicular distance? It is d by 2. What is the sine? 45, 45. Here it is 1 by root 2 plus 1 by root 2. So this is Hs is equal to I by 2 pi d 2 by root 2. So Hs is equal to I by root 2 pi d. So this is a magnetic field due to each side. What is the overall magnetic field? So H total is equal to 4 into Hs, which is equal to 4 into I divided by root 2 into pi. So H total is equal to 2 root 2 I by pi d. Let me go back here, 2 root 2 I by pi d. 2 root 2 I by pi d. So option A is the answer. So it is a very lengthy approach, isn't it? So you need to find out for each section and you have to multiply with the number 4. There is a shortcut for this. This will going to save our time. What is the shortcut? Because on this concept there was a question in the previous paper. For n equal sided polygon with side D and carrying the current, n equal sided polygon with side D and carrying the current I amperes, the magnitude of magnetic field intensity at its center is. This is the formula you must remember. Okay, this will going to save our time. So magnetic field at the center of the polygon. Okay, Ni by pi d sin 180 by n tan 180 by n. So for the triangle n is equal to 3, for the square n is equal to 4. If n is equal to 8, it is hexagonal. Let us take some examples here. See here. If the current carrying conductor is like this, then what happens to the magnetic field at the center? Let us say it is carrying the current I amperes. So H is equal to Ni by pi d. It is 3I by pi d sine of 180 by 3. What is the sine of 180 by C? Sine 60 into tan 60. So which is equal to 3I by pi d root 3 by 2. It is root 3, which is 9I by 2 pi d. Suppose if n is equal to 4, just now we have seen as a question. So it is 4I by pi d. Sine of 180 by 4, it is sine 45. And tan 45. So how much is this? Here it is 4I by pi d 1 by root 2 into 1, which is 2 root 2 I by pi d. That is what we have got the answer, isn't it? Here 2 root 2 I by pi d. Yes? Fine. Let us take one more example. If n is equal to 6, it is a hexagonal. Fine. So what happens to the magnetic field at the center? So H is equal to 6 into I divided by pi d sine of 30 tan of 30. 6 into I by pi d, it is 1 by root 2. This one 1 by root 3. So which is equal to this one, it is root 3I by pi d. Okay, that is how you can use this formula to save your time. Yes? Observe this question. This was one of your previous question. Magnetizing force at the center of the square, each arm, how much? 2a, length shown in the below figure is. So this is carrying the current I, is asking what is the magnetic field intensity at the center. So directly you can use the formula what I have given. So H is equal to, how many sides here? 4, I by pi into d. What is the spacing here? It is, side is 2a into sine of 45 degrees into tan of 45 degrees. Yes. So here it is 2I by pi into a. This one is 1 by root 2 into 1. So which is root 2 I by pi into a. Root 2I into pi into a. Option A is the answer. Clear, friends? Okay. Let us have one more question. Here is a question. Directly formula was asked. Yes. H is equal to dash is the expression for the magnetic field due to an infinite linear current carrying conductor. I by 2R, 2 pi R. I by 2 pi R. Option B is answer. Yes. Okay. There is one more question. A long straight wire carries a current I is equal to 10 amperes. At what distance the magnetic field H is equal to 1 ampere? So what is the magnetic field due to a long straight wire? So H is equal to I by 2 pi R. How much is the H? It is the 1, which is equal to 10 divided by 2 pi R. So R is equal to 10 by 2 pi. 10 by 2 pi. Option B is the answer. Option B is the answer. Okay, friends. Yes. So these are all some of the important concepts, formulas. So this must be your preparation. You should focus more on the formulas and you have to solve the varieties of questions. So I have chosen some important topics where we have confidently explained, we have confidently dealt with the questions which are from the previous questions, previous papers. I have also added my own questions also here. Okay. So this is all for now. All the best for your exam.